Okay, so in this question 22, the review, and we're back to buoyancy. So sharks are generally negatively buoyant. The upper buoyant force is less than the weight force. So that's one of the reasons why they tend to swim continuously, because the water that moves past their fins causes a lift force that keeps the sharks from sinking. So the lift force in combination with the buoyant force will keep the sharks then neutrally buoyant. So they need an extra lift force in addition to the buoyant force. So we've got a 92 kilogram bull shark has a density of 1040 kgs per meter cubed. What lift force must be provided by the fins in order for the shark to swim in seawater? And in seawater we're going to have to use a different density, so I should have given you that. That's raw seawater is slightly larger than that of freshwater, so 1020 kgs per meter cubed. Okay, so we need that value. Okay, so for this question we want to figure out what's the difference basically between the weight force and the buoyant force. So we know for like if we think of it, the net force in the shark is 0, we've got a F lift plus F buoyant equals the weight. So the two sort of upward forces equals the downward force. So we're looking for FL. So we need both the weight and we need the buoyant force. So the weight we already have in the sense where we have the mass, we just multiply that by g. So we think about what we need to think about F buoyant. So force lift is m times g, the weight, minus rho of the fluid, g times the volume displaced. But the volume displaced is the entire volume of the shark. Now we don't have the volume of the shark, but we do have its density and we do have its mass. So I'm going to write that over here. So density is mass over volume. So that means that volume is equal to mass over density. And that's of the object. So FL will be m times g minus rho of the fluid, g, and this will be the mass of the shark over rho of the shark. Not to mix up those rows. So I believe if you multiply the 92 times roughly 10, you end up so 9.8 times the 92, you end up with 902 newtons. Rho of the fluid is 1020, so seawater. G 9.8 over 10 to minus 9.8 meters per second squared. The mass of the shark is 92. The density of the shark is given here, and that gives you a value of 884. So again, showing you that the buoyant force is not enough to balance out the weight. So that gives us a difference of 18 newtons. So the shark needs an 18 newton force, lift force, due to its movement with the water.